Good morning friends. Today in this video we are going to see the shortest path algorithm, Warshall's algorithm. It is also called as Floyd's-Warshall's algorithm. In the previous video we have seen Dijkstra's algorithm for finding out the shortest path algorithms. The disadvantage of this Dijkstra's algorithm is Dijkstra's algorithm is used only to find out the distance between single source and the multiple destinations. But the Floyd's-Warshells algorithm is used to find the distance between all sources and all destinations. That's why the Floyd's-Warshells algorithm is called as all pairs shortest path algorithm. And it works with either positive weights or negative weights. But Dijkstra's algorithm will not work with negative weights. So we'll see this Floyd's-Warshells algorithm with an example at first. I am taking this graph. In this particular graph, I am having the four vertices. So the four vertices are represented as the row and a column here. That is, rows and columns are the vertices that we are having. Here the values that the adjacency matrix that we are creating is the distance between the nodes. 1 to 1 is 0, 1 to 3 is, if you see, infinity because there was no root, and 1 to 2 it was 3, and 1 to 4 it was 7. Likewise we are representing from 2 also. 2 to 1 it is 8, 2 to 2 it is 0, 2 to 3 it is 2, 2 to 4 there was no root. Similarly from 3, 3 to 1 it was 5, 3 to 2 there was no root, infinity, 3 to 3 is 0, 3 to 4 is 1. And similarly from 4, 4 to 1 is 2, 4 to 2 is there was no direct root, 4 to 3 there was no direct root, 4 to 4 is 0. By taking this particular A0, that is adjacency matrix 0, now we are going to construct the adjacency matrix of path 1 length, that is it is A1. When we are considering this particular thing, this is the A0 that we have constructed. We are keeping the diagonals here. For finding out the A1, we are taking first row and the first column. See, the value that we are getting here is, we want to find out these particular values. The empty places what we have left out here, we want to find out this one. See how we are finding out this particular value. We are finding out this particular value in such a manner that it should be minimum of this value and the addition of these two things. So if you see, the minimum value, the value that we are having here is 2, and the addition of these two, that is 8 and infinity, is infinity. So 2 comma infinity, which one is minimum? 2 is minimum, so we are keeping the 2 like that. And in this place it was minimum of infinity comma 8 plus 7, that is 15. So 15 is less when compared to the infinity, so 15 is placed. Now as a application wise, when we are seeing this one, we are writing this particular thing as it is a minimum of A0 of 2 3 and A0 of 2 1 plus A0 of 1 3, because it is a first row, first column that we are considering. Here in all the steps we are getting ones only. So see here, it is a minimum of A0 of 2 3 and the sum of A0 of 2 1 and A0 of 1 3. That is the value that is present in the row and the value that is present in the column is considered. The value present in the row is 8. The value that is present in the column is infinity. 8 plus infinity. Already 2 is there. So 2 is minimum, so we are keeping the 2 value here. And this value that we are finding out in such a manner that it is a minimum of A0 of 2 4. A0 of 2 4 and A0 of 2 1 plus A0 of 1 4, that is the value present in the row and the value present in the column. 8 plus 7 is 15. So 15 is minimum when compared to this thing, and we are representing the 15 here. So this is the way in which we have found out this particular row. Now when we are finding out this thing, so how we are calculating, see here, it is the minimum of infinity and 5 plus 3, that is 8 that we are getting. So value of 8 will be placed here. This is already the value of 1 is present and now we are calculating 5 plus 15, it is 20. So 1 is minimum, so we will be keeping 1 only. That I will show in the next step. See here, we are finding out the minimum of 3, 2, and we are finding out the sum 5 plus 3. 5 plus 3 is 8, and already the value that we are having is infinity. Which one is less? Is infinity is less, or value calculated 8 is less? 8 is less, so we are keeping the value 8 here. See here, for finding out the value present here, already 1 is present. Now we are calculating 5 plus 15. It is 5 plus 15 value that we are placing, and it is value of 20 that we are getting. So we are placing the value, sorry, 5 plus 7 we are placing the value 12 is greater when compared to the 1. So we are placing the 1 only here. So now for calculating this particular 4 step, I am taking which one is less that we are having. When we are considering this particular value, already infinities are present here, both the values. Now I am calculating the value, see here, 2 plus 3. So 5. Is the 5 is less or infinity is less? 5 is less. So we am placing the 5 in here. And similarly, for finding out the value present here, it is 2 plus infinity, that is infinity. Already infinity is there. So the value infinity will be left out here. So for finding out this particular thing, see here, it is minimum of a0 of 4, 3, comma, a0 of 4, 1 plus a0 of 1, 3 that we are taking. This is the way in which we are writing that particular thing. Now taking this a1 as a basis, now I am going to calculate the a2 value. For the calculating of a2, we are considering second row and the second column. So how this particular second row and second column has been considered and how it is being done, we will see here. Diagonal elements will be as usual. Now we are taking the value, this a2 of 1, 3. How to calculate the a2 of 1, 3? It is the minimum of a1 of 1, 3. It is infinity, and the sum of the value that is present in the row and the value that is present in the column. In the row it is 3, in the column it is 2. 3 plus 2. 3 plus 2 value is 5. So infinity is less or the new value 5 is less. So 5 is less, we are placing the 5 here. And for calculating the value here, already 7 is there. And the value that you are calculating is 3 plus 15, it is 18. Is the 18 is less or 7 is less? 7 is less, so 7 value is placed here. Now for calculating the values present in the next step, that is at the end of this step, we have got 0, 3, 5, 7 here. Now to find out this particular value, now already the value called as 5 is present here. Now what we are doing, 5 and the minimum of 5 and 8 plus 8, 16. 16 is less or 5 is less? So 5 is less, so 5 we are placing here. Now for calculating the value present here, it is 8 plus 15 that we are getting, 23 is the value that we are getting. Already 1 is present here. So 1 is minimum, 1 we are placing here. Now for calculating this particular fourth row, the value called as already 2 is present here. Now we are calculating 5 plus 5, that is 10. Is the 10 is less or 2 is less? 2 is less, so we are placing 2 here. For calculating the value here, 5 plus 2, it is 7. And already infinity is present. Is infinity is less or 7 is less? So 7 is less, so we are placing a value of 7 here. This is the way in which we have calculated this A2. Taking this as a basis, now we are calculating the A3. A3 we are calculating by taking the third row and the third column. So now how these particular values are being found out. See here, the value already 3 is present. Now when we are calculating 5 plus 8 you are getting. 5 plus 8 is 13. Is the 13 is less or 3 is less? 3 is less, so value called as 3 is kept here. Now for finding out this particular value, the value present in the row is 5, the value present in the column is 1. 5 plus 1 is 6. Already 7 is present here. Is 7 is less or the new value 6 is less? So value 6 is less, so we have replaced 7 with 6. Now to find out the value present here, Now already the value 8 is present. Now we are calculating 5 plus 2. 5 plus 2 is 7. So 7 is less when compared to the 8. In the next part we will see that here the 7 will be coming. And if you see here the value, what is the value that you are getting? Already the value called as 15 is present. Now we are adding 2 plus 1, 3. So 3 is less, so 15 is replaced here. This is the way in which we have done this one. So the values 7 and 3 came here because 5 plus 2 is less when compared to the existing value 8. And in the last row, for finding out the last row, already the value called as 2 and 5 are present here. So 5 plus 7 is 12. 12 is greater when compared to the 2. So 2 is left out like this. And 8 plus 7 is 12. And already the value of 5 is present here. So 5 is less when compared to the new value that we have found out 15. So 5 is left out like this. So this is A3. By taking this A3 as a basis, now I am finding out the A4. So diagonal elements were kept out like that, and fourth row and fourth column is considered here. And we want to find out the new values that are present here. See here, this value that you are getting, row value and column value, add 6 plus 5, it is 11. And already 3 is present. Which one is minimum? 3 is minimum. So 3 is kept out like this. And for finding out the value here, it is 6, the value present in the row, the value present in the column. 6 plus 7 is 13. And already existing 5 value is there. So 0, 3, 5, 6 were like that only. Now we want to find out the value present here. The value present here, how we are getting the value present in the row is 3. The value present in the column is 2. 3 plus 2 is 5. And 7 is present here. So in the next diagram we will see that 5 is replacing this 7. And for finding out this particular value, it is 7 plus 3, it is 10. And already 2 value is there which is less. So we are placing that particular value here. Now how to find out this particular third row? See here the value present in the row is 1, the value present in the column is 2. 1 plus 2 is 3. And already the value of 5 is present. Is the 3 is less or 5 is less? 3 is less. So 3 value is placed here. And for finding out the value present here, 1 plus 5, 6. And the value called as 5 is present here. So we are leaving 5 like that. This is the thing that we are having. I have given the formulas how we are placing here. This is the A4 value. This is the adjacency matrix by taking the length of the 4 up to the length of the 4 path. And if you see the algorithmic implementation, at first in the step 1 we are creating the adjacency matrix called as A0 of the graph, and then we are taking the I value varying from 1 to the number of rows, and j value varying from 1 to the number of columns, and k value varying from 1 to the number of rows or columns. Because it is a square matrix, the n value will be row length and column length is same. And the formula that we are having is ai of ij is equivalent to minimum of ai minus 1 of ij and ai minus 1 of ik plus ai minus 1 of kj. This formula will be similar to that of the matrix multiplication formula that we are having. And this Warshall's algorithm is also used for finding out the transitive closure of a graph. So how we are finding out the transitive closure of a graph? So this is the adjacency matrix that we are taking for the unweighted graph that we are having. The formula that we are having is Rk of ij is equivalent to Rk of ij or Rk minus 1 of ik and Rk minus 1 of kj. We will be working in a similar fashion of the previous example for finding out the transitive closure. I'll explain in the next video about the finding out the transitive closure of a graph. And this Warshall's algorithm is having a lot of applications. Some of the applications for finding out Warshall's algorithm are, it is used to solve the problems like shortest paths and transitive closure of a graph and inversion of the matrix like a Gauss-Jordan algorithm and optimal routing between the two vertices and fast computation of the pathfinder networks or finding out the widest paths or the maximum bandwidth that is available in the networks.